Hi, this tutorial series is for chemical process modeling and control. Here, I shall be explaining and possibly make some amendment to the MATLAB codes written by Ewetoye in their textbooks titled Essentials of Process Control. Even if you don't have the textbook but you just want to know how to employ MATLAB in solving some process control problems, you may come along also, as I will show the problems leading to the code. In this video, I will be dealing with the MATLAB codes on page 56 of the textbook, where we are going to be studying the response of a system both in its open loop and closed loop states by solving linear ordinary differential equations. Here, we consider a three-heated tank process. The process is described by three linear odes. If the flow rate F volume V, assuming equal volumes in the three tanks, and physical properties ρ and Cp are all constants, these three equations, that is the linear odes, can be converted into perturbation variable by inspection. By simple mathematical manipulations, the equation can be put into the following state space representation, where x is the vector of the three temperatures T1, T2 and T3, u is the vector of the two inputs T0 and Q1, y is the vector of the measured variable T3, A, B, C, D are matrices of constants. And for open loop states, A is equals to this, while for closed loop states, A is equals to this, B for open loop states, and is equals to this for closed loop states. The disturbance is a drop of inlet temperature T0 from 90°F to 70°F. Hence, we shall be writing for a -20 step response at different controller gains. Here is the code for calculating the response. I have modified the code in several forms. The first part of the code calculates the open loop response to -20°F step disturbance in the inlet temperature T0. The first executable line is for cleaning up the run. The next four lines are for defining the open loop matrices, after which the time vector is clearly defined, followed by setting the inlet temperature disturbance. To get the time response for unit step in the inlet temperature disturbance T0, we invoke the built-in step function, which in the case of state space representation takes the constant matrices A to D, the disturbance matrix U, and the time vector T to produce the unit step response, that is a 1°F step response. Without the y and x in front of the function, it will produce a plot of a 1°F change in inlet temperature. But for the task at hand, we need that of -20°F change in inlet temperature. Thus, we pass the y-axis value to y and other values to x. It is the values of the y-axis we need for scaling up or down to the required step response. And in this case, we are going to be scaling down to -20°F before plotting. We are going to be scaling down to -20°F before plotting, which is done in the next executable line. The plot is then titled and labeled appropriately with the grids shown. In the second part, we deal with the closed loop step response. We define the closed loop matrix A to D. Here, we are forced to leave out the matrix of A, as it changes with the values of Kc, which takes on several values. The values of Kc is defined here. This code is a modified version of the ones written by Ewetoye, as the values of Kc can be increased from 2 values to say 5 or even 6, and the code will still run without errors. This will be tried later. Length of Kc is gotten with the numeral function. For now, since there are only 1 values in Kc, we expect the length to be 2. The next line is just for pre-allocation. It is not necessary for us to pre-allocate, but it is used here just to have a clean lines of code, as signified by the green indicator. We want to leave the open loop figure alone. Hence, we call a new figure, figure 2. for plotting the closed loop response on a separate figure. Line colors is used here to distinguish the response for different values of Kc. A for loop is invoked to compute matrix A and plot the step responses at different values of Kc. AL3 is the third element of the closed loop matrix A, which is dependent upon Kc. It is computed and fed to the closed loop matrix A on the next line. The unit step response is taken and then scaled down to -20 degree Fahrenheit, and then scaled down to -20 step response and plotted with different colors depending on position of the current values in the Kc matrix. The names of the legend is updated, and the old command is meant for plotting all the closed loop responses on the same figure 2 without erasing the previous one. The figure is then labeled appropriately. Now let's try 4 values of Kc, say 2, 5, 7, 11. Thanks for watching. If you have any questions, suggestions or correction, you may post it in the comment section or mail it to me. See you in other videos.